Hello and welcome back to Wildcard CAD with Jeff. We're going to run through another SolidWorks example. And this one is a shell feature. Pull it up here. And what they also want us to do is some parametric design. And it's not terribly different from the others, so we see that D is really the only one that's used three places. The other three are just single. So we'll start our sketch on this part. And we're going to start with question 1, with A being 60, B being 64, C being 140, and D being 19. And let's go ahead. And we will go File New, opening a new part. And this will be in inches, so you want to come up to the top, Options, Document Properties, Units, and you see we're an inch. We're going to switch to millimeter. Okay. Now we're going to start our sketch. I am going to sketch this on the right plane. And C is our first dimension was 140. So we'll start with that. And you know how I like to use centers, so we're going to go ahead. Constrain the center line, or the center of that line, to the origin. Coincident. And the length for C, we're going to drop this down, is going to be 140. We're going to update the name of this dimension to C. Okay, next we have D over here, which is going to be used multiple places. It's going to be 19. So same idea. 19 for now. And this will be D. Take a look back at our part. And we see that we have 90 is the length here. Coming up, that is going to stay constant. And what is going to change is our A. We're going to start with 60 degrees. So all I'm going to do, start a new line, rough it in, put in A first, 60 degrees, and that will be A. And I believe the length was 90. Let's double check that. Yes, 90 millimeters. Very good. And just to take a look at the part again, what we're going to do is then come up over here. And then we'll wrap back around with D as being the thickness for the entire part. And the length here, we're going to have 51 plus, for a full round, the radius will be B over 2. So our radius will be 32. So 51 plus 32 is 84. And this is going to change, and I'm not involving the global variable B in it. We're going to have to do that by hand. Now everything's just going to be D all the way around for this. So we'll come down here, come up parallel to that. To there, back around. And real easy to make this all stay the same the whole time. Get on there, equal sign, And you can just click on the dimension, shows D there. Same here. Equals D. And now we are fully constrained. We're going to go back to look at the thickness of this part, which is B, that is 64. So features, extruded base. It's always good practice in parts like this that are symmetric. Um, I'm already on midplane because that's what I use a lot. That was 64. And shoot that out. Beautiful. Now we're gonna get to our shell here shortly. Let's see what other features we have. We've got everything. We're gonna put in the fillet now. And that will also be 32 again on both sides. Thirty-two, added that there. And that should give us a full round. There we go. Now, here's the trick. You don't want to put that cut in first before the shell of the hole here. See, because what'll happen if you do that? You're gonna get an extra thickness coming around up there that we don't want. So we're gonna shell first, then we see the shell is 3 millimeters. So shell up here in the toolbar, set to 10, we're gonna go to 3, and we're gonna pick that face. Now we're shelled all the way down there, and now it's time to cut this circle. You could either use the hole master, or you could use or the hole wizard, or you could draw a circle. A little easier for time's sake in these tests, I think, to just draw a circle, but best practice would be to use the hole wizard. This is 19 for the diameter. And then we're going to do an extruded cut so we don't go too far, and we're selected up to surface. That's this drop down right here. Usually blind is going to be your go-to up to surface for this situation so we don't cut too far and go all the way through this part. There you have it. That's the part. Now we've got to get our material was brass. So we're going to go edit material. So right click there. And that will be in copper alloys. Brass, apply, close. Now let's see what we get. This doesn't have an answer on it, so I'm going to let you verify me. Go to the Evaluate tab, Mass Properties, and what I am seeing is 1009.36 grams. Again, that's 1009.36 grams. So that's what you want to get for the first part. Now we're going to modify this to meet the second set of dimensions. So the first thing that's going to change, we're going to change the angle A to 50. That will be again back here. We're going to go to our boss extrude, edit sketch from 60. Now that's going to be 50. And that's our A. There we go. Let's see what changes next. B was 64. Now B is 70. So that'll change our length here. That'll be 51 plus 35, So 86 is now what that'll be up there. And like I said, we did that manually. 86. Coming back. C was 140. Now C is going to be 160. Good. And coming back again. D was 19 going to 23. And here's the magic part. It changed all three Ds at once. Very nice. Now that is good. We can finish there. Exit the sketch. Only thing that is off is this fillet. Now should be 35 for the radius. Because 70 is the thickness, we have a full face fillet. And when we pop that in, perfect. Let's take a look at what we've got. There's the part. Let's see their part. And we're going to see the dimension here. We're shelled. We have updated all of these. Let's get our weight, and you can check me. Comment below if I'm wrong. I'd love to hear it. Mass now, still same brass, but the mass is increased to 1,145.36 grams. Again, that's 1,145.36 grams. So check me on that. Tell me how you did it. Maybe we did something different. And hey, let me know. I could be wrong. I'd love to learn that. So get back to me, and I'll be back to you sometime soon. Thank you.